This is Modern Physics, Physics 3310. I'm Dr. Formica, and I look forward to seeing you all on Monday. I'd like to jump right in and start talking physics first thing on Monday, so I made this video for you so you can learn about my goals for you in this class and how the class is organized. Please watch it before Monday because I won't be going over this information in class. I'd like to start with something Neil deGrasse Tyson once said. Knowing how to think empowers you far beyond those who know only what to think. My number one goal of this course is to help you to learn to think like a physicist. But what does that actually mean? In this class, of course, you will need to learn about what to think. Specifically, you'll learn about physical laws of nature like Einstein's postulates of special relativity, Heisenberg's uncertainty principle, and the Pauli exclusion principle, just to name a few. But what Neil deGrasse Tyson was referring to, how to think, is understanding these physical laws and knowing how to apply them to solving problems. This is the hardest part of physics, and this will be my focus throughout the course. In this class, we'll use a problem-solving methodology called the IC method. IC stands for Identify, Set Up, Execute, and Evaluate. Whenever you begin to solve a problem, you'll start with Identify. You'll identify the relevant information that's given, you'll state the information that's implied, and you'll state what you need to find in the problem. The most challenging part of this step is identifying the physical concepts or laws that are involved. It'll take practice to hone this skill, but we'll discuss how to do this every day. As long as you keep practicing, I promise you'll get good at this. The next step is the setup. Every problem you solve will require some kind of physical representation. You'll need to draw a sketch of the situation according to the problem description. You'll also represent the problem mathematically, usually with an equation. The hardest part of this step is estimating what your result should be, or predicting the physical behavior of the system, but this is super important. A physicist always does an estimate of a calculation before doing the hard work. We always want to know if our actual result makes sense. Again, it'll take practice to get good at this, but we will do it often. The third step is execute. This is where you work through the math. Even though it doesn't seem like it, this is the easy part. At this point, you've already done most of the critical thinking, the hard part. But during this part, you'll need to work through the math without plugging in numbers. Wait until the last step to plug in the values given. This makes it simpler to follow your work when I'm checking it or when you go back and check your own work. Plus, it leads to fewer mistakes. Most mistakes are made when you plug in numbers too early and then try to do the algebra with these numbers. Trust me, I've seen this happen over and over again. Also, something critical. You'll need to always have units with your numerical answers. Always. Otherwise, the answer is wrong. The number 5 is meaningless unless it has units. 5 meters or 5 seconds means something, but just the number alone doesn't. The final step is evaluate. When you get a result, you always need to ask yourself, does this answer make sense? If you're finding a speed of, say, a person running, and you get 86 miles per hour, you know this is unreasonable and you must have made a mistake somewhere. If you're finding a time and your answer has units of meters, you'll need to go back and check your work. Remember how you made an estimate of what your answer should be earlier? This is where that comes in. Is your final answer somewhat close to what you predicted? Sometimes you'll solve a problem that doesn't have a numerical answer, but instead you might need to solve for what we call an algebraic solution. This means that the solution is an equation. To check a solution like this, you need to see what happens in limiting cases. This means you plug in a really small value, like something close to 0, and see what happens. Then you plug in a really big value, like something close to infinity, and see what happens. This might not make sense now, but we will practice it together so that it does make sense. To learn to think like a physicist, you have to practice talking physics. So in this class, you'll talk to each other a lot. In class, you'll work in groups to solve problems. You'll talk to each other about how you solve the problem and why you think your solution is the best method. You'll argue, in the friendliest possible way, how to solve these problems. This will help you and your classmates learn. Also, before class, you'll read the textbook and discuss the text with each other using a program called Perusall. You'll need to go to Perusall.com and register. It's free. When you register, you'll be asked for an access code, which is Formica ESHLL. There will be reading assignments for each chapter we cover, and you'll need to complete the assignment in order to take the quiz for that chapter. This site is pretty easy to navigate, so go ahead and sign up and then start clicking around to see how it works. When you open one of the reading assignments, it will look like this. If you click and drag across the text, you can highlight it like this. Then a conversation window will open, and you can type your comment or question. What you type will be shared with me and with the rest of the class. You can also comment on threads that have already been started by other students. You can answer each other's questions, ask your own questions, or just continue with the discussion. To get full credit, you'll need to make at least 5 thoughtful annotations, and they will need to be spread evenly throughout the assignment. There will also be assignments that have problems to solve, and you'll access those through Mastering Physics. To access the course page, you'll need to go to pearson.com/mastering. It's imperative that you go to this specific site, otherwise you won't be able to access the course page. I'll put a link to it in D2L to make it a bit easier for you. When you get there, you'll need to register, so click here. Then you'll come to this page. Click here. And when you're prompted for a course ID, it's Formica 76276. Then click Continue and follow the rest of the registration steps. You'll need an access code, which the physics department will purchase for you. So don't purchase anything. Just sign up now with temporary access. This will give you 2 weeks of access so you can do your assignments before we give you your access code. Oh, and the textbook is included as an e-text, so if you're okay with just using an electronic version of the book, you don't need to purchase a paper copy. When you get registered and get into the course page, it'll look something like this. There are lots of different types of assignments available here, so just like with Perusall, register and then take a look around. Rather than grading each assignment with partial credit and then taking a weighted average of your assignments to find a grade, this course uses a set of course expectations called specifications, or SPEC for short, and each SPEC has an associated quiz. To pass a quiz, you must perform at a mastery level, which is usually equivalent to what would have been an A with traditional grading. And your final grade is determined by how many quizzes you master. Each quiz will be scheduled as a 10-minute in-class quiz. You will also have the opportunity to retake a quiz. We all learn a little differently and at different rates. Sometimes we need a bit more time and practice to master a difficult concept or skill, and this is why you'll be able to retake a quiz. However, you must earn the privilege of taking the quiz or the retake. To take what I call the version alpha quiz, you must complete the Perusall reading assignment at a mastery level before the quiz is administered in class. To take the version beta quiz retake, you must complete the practice quiz assignment in Mastering Physics at a mastery level. Version beta quizzes may be attempted no more than 2 weeks after the scheduled day for version alpha. If you do not master the beta quiz, you may attempt a gamma version. To take the version gamma quiz retake, you must make an appointment to meet with me for one-on-one tutoring before attempting the gamma version. Version gamma quizzes may be attempted no more than 1 week after the version beta attempt. And finally, you may take a final version, delta, of up to 3 quizzes during the final exam week. This is the last chance to improve your grade. You'll need to schedule an appointment with me to retake any quizzes during finals week. There will be a reading assignment for every chapter, and you are required to complete the reading and annotations before the quiz for that chapter. You should aim to read and annotate before class. The sections we'll be discussing in class that day. The last page of the syllabus contains a schedule for the semester so you can easily see what sections we will discuss each day and when the quizzes are scheduled, so take a look at that. For each chapter, problems will be assigned in Mastering Physics for you to practice. One problem from this practice quiz assignment will be on the quiz for that specification. Remember, to take the version beta quiz retake, you must complete the practice quiz assignment in Mastering Physics at a mastery level. After each class, one problem will be assigned in Mastering Physics for you to solve before the next class. These daily problems are not required, but keeping up with this work can benefit you. Not only will you get much needed practice in problem solving, you may receive extra credit on your final exam grade. You will be awarded 1 point on your final exam for demonstrating mastery on the daily problems. Before most classes, pre-lecture videos will be assigned in Mastering Physics for you to watch before each class. Each video has questions to answer afterward. You'll be awarded 1 point on your final exam for demonstrating mastery on the pre-lecture video questions. And for each chapter, tutorial problems will be assigned in Mastering Physics. Again, you'll be awarded 1 point on your final exam for demonstrating mastery on the tutorial problems. Another extra credit opportunity is called Learning Catalytics. In class, every day we'll solve problems. Using Learning Catalytics, which is part of Mastering Physics, you'll submit your answers to problems using your phone or computer. You'll receive credit for submitting a response, and additional credit for submitting the correct response, and you'll be awarded 1 point on your final exam for demonstrating mastery on the Learning Catalytics problems. Bring a phone or computer with you to class every day, but we do have classroom laptop computers you can borrow if needed. And at the start of each class, there will be a 1-minute quiz on a physics formula. In order to think like a physicist, you have to be able to speak the language, so that means you'll need to know the fundamental formulas we use every day in physics. I'll give you a list of what you need to know, and you should study this list regularly. Your first daily quiz will be this Wednesday. You'll be awarded 1 point on your final exam for demonstrating mastery on the daily quizzes. Okay, so what should you do now? Go to D2L and look at all the course materials I've provided for you. Also, read the syllabus. There are more details about the course and the assignments that I didn't go over here. If you haven't done so already, go to Register at Perusal and Mastering. You can get to these links through D2L if you prefer. I've already assigned reading and perusal. Since I plan to start doing physics right away on Monday, you should start reading the chapter that we'll be discussing. And finally, please send me an email if you have any questions or if you have any difficulty registering for any of the websites. I'm happy to help you in any way I can, and I'll see you Monday.